For this example, we're looking to convert this quadratic function in standard form into vertex form. So the benefit of a vertex form is that it allows us to quickly and easily locate the vertex directly from the equation. So the value of a here still determines whether our graph opens up or down. If a is positive, it opens up. If a is negative, it opens down. But you can see that we have this quantity x minus h being squared and then plus some constant value k here. So we actually get our vertex directly from these values in this equation. So our vertex has the ordered pair, so the vertex has the ordered pair h comma k. So we can actually get it directly from our equation when our equation is in vertex form. So let's look at how we will convert this standard form equation into vertex form. To convert it into vertex form, we're actually going to need to use completing the square. So we are going to complete the square by grouping our x values and completing the square on those so that we can then convert it into vertex form. If you recall, in order to complete the square, the leading coefficient needs to be 1. So we're going to have to factor out a 2 from this. So our function is going to look like this, f of x equals, so factor a 2 out, 2 times the quantity x squared plus 4x, and then leave ourselves some space, and then we still have this plus 5 here. So in order to complete the square, we know we want this to be a perfect square trinomial, so we're going to be adding some value here, and then that way when we factor it, it can factor in to be some quantity squared, x minus some quantity squared. So to complete the square, we take our middle term divided by 2 and square it. So 4 divided by 2 is 2. 2 squared is 4, right? So 4 divided by 2 is 2, and then we square that value to get 4. So we add 4 in here, and that's going to make these three terms a perfect square trinomial. But we can't just add something to our equation without any consequence. That would change the value of our function. So we need to subtract the same value from our function as well. But really, we're not adding a 4 here. We're really adding a 2 times a 4 because this 2 is going to be distributed through to all three terms. So we're really subtracting 2 times that 4 that was added on the inside. So now we just factor this function. So f of x equals 2 times the quantity. So this factors to be x plus 2 times x plus 2. So it's x plus 2 quantity squared. And then take this sum. This is going to be 8. So it's 5 minus 8, which is going to be negative 3. So our function f of x equals 2 times the quantity x plus 2 squared minus 3. So if we think about this in vertex form, really what this is saying is f of x equals 2 is our value of a, and then it's x minus a negative 2. So this negative 2 is our value of h, plus a negative 3, and this negative 3 is our value of k. So we know this value here is h, this value here is k. So our vertex, the vertex for this function, is going to be negative 2, negative 3. And then we know that our graph is going to open up because the value 2 here is positive. So this opens up. Now, what does our graph opening up tell us about our vertex? Right? So if our graph opens up, that means it looks something like this. Something like this. The vertex is actually just either the maximum or minimum value of our quadratic. So if our graph opens up like this, our vertex is going to be this value here. That's our vertex. And so if the a value is positive, that tells you that your vertex is a minimum value. So this is a minimum. If the a value was negative, right, so this is for a values greater than 0. If the a value was negative, our graph opens down. which means that our vertex up here is going to be, so that's our vertex, which means our vertex is going to be a maximum. So if our graph opens down, our vertex would be a maximum. In this case, it's a minimum because our graph opens up.